So, good day everyone. Our topic for this advanced managerial statistics is two-way ANOVA using MS Excel. Again, ANOVA stands for analysis of variance in test for differences in the effects of independent variables on a dependent variable. So, a two-way ANOVA test is a statistical test used to determine the effect of two nominal predictor variables on a continuous outcome variable. So a two-way ANOVA test, the effect of two independent variables on a dependent variable. So a two-way ANOVA test analysis, the effect of the independent variables on the expected outcome along with their relationship to the outcome itself. Random factors should be considered to have no statistical influence on a data set, while systematic factors would be considered to have statistical significance. So by using ANOVA, a researcher is able to determine whether the variability of the outcome is due to chance or to the factors in the analysis. So ANOVA has many applications in finance, economics, science, medicine, and social science. Okay? So now I will share to you the video presentation on how we will be able to compute the two-way ANOVA using Microsoft Excel.
In this video, I'd like to talk about the process of doing two-way ANOVA. In the past, we've talked about one-way or one-factor ANOVA, and if I were to apply those concepts to a new problem, it would be this. We have four different representatives. This could be customer sales reps, could be sales reps, and the number of items of work that they get done, maybe sales, is represented here. Representative 1 gets 1, 17, 17, 20, 22. Those are different values that they sold at different time periods. So doing our traditional one-factor, one-way ANOVA, we might analyze this to see if there's a difference in how much you sell based on which rep is being used. So if I go single factor ANOVA and grab a block of data and then find a place to put this kind of down here arbitrarily, I do get averages for each representative, but the p-value is not significant, and so it looks like just looking at different levels of representative alone as a one-way ANOVA that there's not a difference. However, there might be some additional information we can add to this data set that would help us find something important. So oftentimes we have not just one factor, we have two factors. So we would call this two-factor ANOVA. So here we have the exact same data, but this time we have 5 different districts involved. So imagine then, so let's talk about the representative first. So it makes sense that maybe some salespeople do better work than other salespeople. And so we might be looking for a difference in those things. And so even if this same representative sold in multiple districts, different areas, sometimes some people just have great personalities, they're charismatic, they have better training, they might do a better job. Alternatively though, maybe the area in which you sell has its own effect. So for example, what if you were selling some high-end item like timeshares in an expensive area like Key Largo, and so you sell in maybe a poor urban area of a given state, or maybe a really rich neighborhood, and so maybe the area that you sell in, regardless of the representative, makes a difference. So let's look at both of these things simultaneously. The way we do that is we go to data analysis, two-factor without replication ANOVA. Now what that means is that for any one of these rows we only have one data point. If we had multiple measurements of representative working in District 1, we will call that with replication, but for right now we're doing without replication. So I'm going to grab my input range and I'm going to say I've got labels and I need a place to put my data. Alright, so there's my output. I see some averages for if I'm in one district or another, and I see some averages for different representatives. Now let's see if either of these factors matter. And so I look down and it says that my p-value is 9.74 times 10 to the negative 5. So that sounds great. That means it's highly significant. And what's highly significant? The stuff in the rows. What's in the rows? That was the districts. So we know that districts matter. Another thing, the columns. That's less than 0.05, so we'll say that that's highly significant, that matters as well. So ironically, even though by itself representatives didn't seem to matter, when we look at both of them at the same time, we were able to detect that representative does matter if you take into account districts, and districts have their own standalone effect as well. Alright, so once we've determined that that something is significant, then we can use that as part of an overall predictive model. So and if we didn't find things that were significant, then we couldn't really say anything. So I have a list of steps that you go through right here, that if you want to predict now the sales in a given area, you take the overall average, add the representative effect, then add the district effect. So that means that if I want to, I need to consider the combination of both the representative and the district in making a prediction. So I'm not making some overall prediction, I'm making a very specific prediction about a given cell. So I've done the math right here, but let me do it a second time. Let's just say that I want to get an estimate for representative 4 in district 2. How would I do that? Well, first off, I need an overall estimate. So I type in equals average. So 17.6 is the average sales across the entire data set. Now I want to consider representative 4. Now so what does that mean? In an intuitive sense, think about this as there's a regular mean, and does this mean go up or down if you're representative 4? Well, how would you know that? Well, take the average of whatever they sell, and is that above or below the mean? And then we'll take that into consideration in our formula. So I'll say equals the average of this minus our overall average. And what we see is that it looks like, and maybe I should just put it out to the side, equals average of this, and actually this was contained below 21.2. I could have scrolled down here and said, oh, representative 4 actually sells 21.2. I could have gotten it there as well. So 21.2 is 3.6 higher than the average. So we're able to say that there's a positive net effect of above the average of 3.6 sales because you've got representative 4. Now what about the effect of district 3? Or district 2 in this case? Well, this time I'll just go down here and look it up. So the average in district 2 is 14.75. So I'll say equals 14.75 minus the average. So 14.75 is worse than the average, so that means that there's going to be a depressing effect. We're going to lose some sales because we are selling in district 2, regardless of the salesperson. So we add up all of these effects here, the average, the increase for being representative 4, and the decrease for being in district 2, add all those numbers together, and our prediction is now 18.35. If I want to do a confidence interval, now because remember this is just kind of a guess or an estimate, so if I want to say I'm 95% sure of the range of the actual value in that cell, I would take the square root of this value right here, and then I would do so equals square root of that, and then I would multiply that by 2. So I would take the amount that I just came up with, 18.35 plus 7.9 and minus 7.9, and that would be the upper and lower bounds in which I would say I'm 95% confident that the actual forecasted value will be within that range. All right, now I'll go on to my next one. Now here's a different case. Instead of talking about representatives and districts, now I'm talking about the impact of price and advertising, and I've labeled this no interaction. The data has been set up so that we don't think that these two things will interact on this tab. However, in the real world they probably will, and we'll see that in the next tab. But if you think about the effect of price and advertising, that if you pick any product like an iPhone, that the lower the price, the more you'll probably sell, the higher the price, the less you'll probably sell. Similarly with advertising, the less advertising you do on a product, the less you'll probably sell. The more advertising, the more sales that you'll probably make. But if you combine those things together, if you have like an abnormally high price, then it doesn't really matter how much advertising you do. If you make the iPhone 3 times the rational cost, then probably nobody's going to buy it. On the flip side, if you make the price ridiculously low and then you have super high advertising and everybody finds out about it, then you're probably going to have a really good result. So there's actually what we would call, in principle, there should be an interaction effect between these two things. But let's just go ahead and do another ANOVA. This one is going to be really just to demonstrate the idea of replication, meaning that in a given cell of low price and low advertising that we have three different observations. So I'll show you how that works. We're actually not going to get an interaction here, and that's on purpose. So ANOVA two-way with replication. So I'm going to grab my input range. I'm going to say rows per sample. That's how many rows in each of these cases of a certain type. And then I'm going to output my data somewhere, and I'll put that right here. Alright, the first place I typically go to is my ANOVA table, and it shows me this word sample, columns, and interaction that have p-values. Now sample in this case, it used to be rows when there was only one row, but when there's multiple ones, Excel calls it sample. So it says that the rows matter. Rows and groups of 3 matter. That's highly significant, as is columns. And then we have our interactions, which is not significant. So we won't talk about that yet. Alright, so because we have determined that there is an impact of the level of the column and the level of the row, we can now move forward with that in creating a prediction. And so I didn't write this here, I should have, but my formula for my prediction will be the total sales equals overall average plus price effect if significant plus advertising effect if significant. Okay, so again, we need, in order to test out our predictive formula, or use it, apply it rather, for prediction, we need to pick out a given area. So we want to know either here or this block of 3 or somewhere. We're trying to say, what is the estimated benefit, or what's the estimated outcome in sales if we have high price and low advertising, for example. Well, let's start off building our formula then, and we'll say our overall average, I've actually computed that right here, average of D4 to F12, so just the whole thing. So we'd say this is going to be 25.037. Okay, now we need to potentially add on any impact from the price being significant, and it is. We found out that the columns were significant. Actually, I should have written rows and columns here, but now I got to kind of work a little backwards. So is there an impact of price? The answer is yes, of course, but what is that impact? Well, it's kind of similar to this idea that we had before, where we're checking for the impact of a representative by taking the average for that case and subtracting that from the average. Here we have the average of this particular column of low price. So you take the average of all those numbers and you subtract the overall average, which is there in D1. So what this is telling us is if you have low price on a product, that there's an 8.9 unit increase in likely number of sales. So that shouldn't be too surprising. And so we're going to say, if we're testing low price, high advertising here, we would say, I'll just kind of say I'm adding in 8.96. And then if we want to know what the impact of having high advertising and with my low price, same idea. I take the average here of everything in high and then subtract out the value from the overall average, and so that's what you see. So the average of D10 to F12, and then you subtract out the overall average, and what this tells us is that we get a boost of 7.407 or just 7.40 if we spend a lot on advertising. This makes sense, right, in terms of our intuition. So if I just sum up those three items, that will be an estimate of how much I'm going to spend, or how much I'm going to earn in sales if I add all those together. If I go in that particular cell, based on the fact that my rows and columns were both significant. Now, so that's a particular case that we're looking at. Now, if we wanted to do a confidence interval, a 95% confidence interval, saying that we're 95% confident that the actual value is plus or minus 2 standard deviations from here, we would get our standard deviation from grabbing this number, taking the square root of it, that gives us our standard deviation, multiply it by 2, that value by 2, and then add or subtract that from that number to get our bounds. Alright, now we'll do something similar over here. This time we've introduced the idea, this data is a little bit different. I'm going to introduce the idea of interactions. So I'm going to do the same approach, two-factor ANOVA with replication. I'm going to grab this block of data. Oops. Don't know why I did that. Okay, two-factor with replication. And in terms of where I'm going to place that data, I'm going to go down here. Alright, let's go look at the results. It says that sample, meaning my rows are significant, columns are significant, but importantly it says my interactions are significant. And once that happens, I can ignore this other stuff because that kind of overrides the rest. So with that being the case, that my interaction is significant, then what I want to do, so this kind of then plays into this, potentially this idea that maybe low price and high advertising have an impact on one another. They work well together. So what I will do is, if I want to have the prediction for any given case group, it's actually pretty straightforward now. It's actually just the average of stuff that's within that group. So I will go, so if I want to know low price, high advertising, I just take the average of those three numbers, and it comes out as 51. If I wanted to know medium price and medium advertising, I could do average of that. And of course I should mention that this is just kind of the estimate for that cell, and if you want to have a 95% confidence range, since it's likely to vary what the actual value will be in the real world, you take the square root of this last item in the mean squared column, which is within, again, take the square root of that, multiply it, and then you got the standard deviation.
Okay, so as our video discussion, as per video discussion, an ANOVA test is the first step in identifying factors that influence a given outcome. So once ANOVA test is performed, a tester may be able to perform further analysis on the systematic factors that are statistically contributing to the dataset variability. So a two-way ANOVA, no, test reveals the results of the two independent variables on a dependent variable. So ANOVA test results can then use in an F test, a statistical test used to determine whether two populations with normal distribution shared variances or a standard deviation on the significance of the regression formula overall. So analysis of variance is helpful for testing the effects of variables on one another. So it is similar to multiple two-sample t-test. However, it results in the fewer type 1 errors and is appropriate for a range of issues. An ANOVA test group difference by group, comparing the means of each group, and includes spreading out the various across diverse sources. It is employed with subjects, test groups, between groups, and within groups. So now, how will be able to differentiate the ANOVA versus the two-way ANOVA? There are two main types of analysis of variance. So one-way or unidirectional, and the two-way or bidirectional. One-way or two-way refers to the number of independent variables in your analysis of variance test. A one-way ANOVA evaluates the impact or a sole factor on a sole response variable. So it determines whether the observed difference between the means of independent groups are explainable by chance alone or whether they are any statistical significant difference between groups. A two-way ANOVA is an extension of the one-way ANOVA. So with a one-way, you have one independent variable affecting a dependent variable. So with a two-way ANOVA, there are two independents. For example, a two-way ANOVA allows a company to compare worker productivity based on two independent variables such as department and gender. It is utilized to observe the interaction between two factors. It tests the effect of two factors at the same time. A three-way ANOVA, also known as three-factor ANOVA, is a statistical means of determining the effect of three factors on an outcome. Okay, so I think that's it for our discussion related to two-way ANOVA.